Hey guys, let's talk about the surface area of a cube. Before I start, I want you guys to know what is area. Area of a rectangle is given as L times B. Now let's do a rectangle here and try to understand what exactly it is. So that is my rectangle. Yep. L, I say that is 2 centimeters and that is 3 centimeters. So I can say the length here is 3 centimeters and the breadth here is like 2 centimeters. Okay. Now, if I just draw squares inside this rectangle, okay, and I call them be 1, 2, 3, 4, 5, 6 squares. I can fix 6 squares inside this, and the size of this square is basically nothing but 1 centimeter, and I can write this is also 1 centimeter. So I call the square to be like 1 centimeter square, or I can say 1 square centimeter. One of these is fine. So when I come back here and substitute the value of L and B, I get 3 times 2 and I can get 6. 6 what? In fact, 6 squares. So I can write 6 squares. And 6 squares are what measurement? Of centimeter, right? So 6 square centimeters. So that's how we understand the area of a rectangle. Beautiful. Now let's talk about area of a square. So area of a square is given as, in fact, square is also given as L times B. But the special case about square is this, that the length and the breadth are equal, so we don't call it to be L and B. So let's say that is 2 and 2. So L here is 2, B here is also 2, since they are same measurements all the time, because a square will have all the sides equal. So we'll take L as A and even B as A. So what happens with the area is it goes like A times A, which we call to be A square. So we call area of a square to be a square. Now let's come back to this square and see how we can find the area of this square. In this case, if I draw the squares exactly the way we did before here in the rectangle, I can see I can fix 1, 2, 3, 4 squares inside this thing. All right. So the length here was 2, the breadth here is 2, or I can just say that the sides, the length of the side basically is 2, and I have to find the area of that particular square of 2 cross 2. And I can say I can fix 4 squares inside this of measurement 1 centimeter. So I can write I can fix 4 centimeter squares inside this, 4 small squares inside this big square. So that is the understanding of area of a square and the rectangle. So we understand that. Let's go ahead and find the area of a cube, surface area of a cube here. And based on this logic, we'll see how we can understand this. Okay. Well guys, let's see how to find the surface area of the cube, the total surface area of the cube, and the lateral surface area. Now that's the cube I have here in the center. And to find the surface area of this cube, let's do one thing. Let's just wrap this cube with a cardboard. Yeah, look at this. This basically I'm just wrapping the cube with a cardboard. Now the surface area of this cardboard is actually the total surface area of the cube also, isn't it? And if I exclude the top and the bottom, that becomes the lateral surface area. So let's unwrap it again. So I'm just taking off, right? So I can see if I can somehow find the area of these 6 pieces of the cardboard, I'm done. So let's do one thing. Let's reverse or just invert the cube so that I can see the faces. There are 6 faces I can see here clearly. 1, 2, 3, 4, 5, and 6, which includes the top and the bottom. Well, we already learned how to find the area of a square. So if I see that the length of this square is, let's say, 4 centimeters, and the height is also like 4 centimeters, or I simply can say that the edge of this cube is 4 centimeters. So what could be the area of this particular square here? It's simple, that we know that area of a square is given as a squared, where a is nothing but the length of the square. So it can be like 4 squared, which is like 16 square centimeters, right? So that is the area of one of this piece. So can we visualize that? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So it means the area of this piece of the cardboard is 16 squares. Can you see 16 squares here? Exactly. So we call each one of them is like 1 centimeter square, and like that we have 16, so we call this be 16 square centimeters or 16 centimeter square. So we can also call that 16 centimeter square. That is the area of this piece. How many pieces like that? So I can say even here we can find 16 square, that is 16 centimeter square. So here also we have 16 centimeter square, 16 centimeter square, so 16 Look at that, that's very simple. And the bottom here is again 16 centimeters squared. So if you add all these, we get the total surface area. What is the total surface area? We can call total surface area of this cube is nothing but 16 plus 16 plus 16 plus 16 plus 16 and 16. So why 6 times? Because I have 6 faces. So we can also write this to be 6 times 16, yes. And it can be written as 16 can be written as 4 squared, and you know what exactly 4 was. 4 is nothing but, let's say, a, that is the length of the edge of the square. So we can write this as 6 times a squared, which becomes the total surface area of the cube. Now if I eliminate the top and the bottom, so how many of them left? 1, 2, 3, 4. So I can write the lateral surface area is nothing but, excluding the top and the bottom, that is 4 times a squared. So we can write this as 4a squared is the lateral surface area of the cube. So we got it, how to find the total surface area and the lateral surface area of the cube.